So we're now at the portion of this lesson where we're talking about something called geometric mean, which is kind of a special way to take a look at these proportions that we can find within right triangles. We're going to be walking through one of the two types of geometric mean, and really there's two different kinds of proportions that we can set up. Those are also shown as theorems. Theorem 7.6 is the geometric mean having to do with an altitude. We're going to look at that specifically, but if you look down below, Theorem 7.7 is geometric mean. That's the leg theorem. Okay, so that one's set up differently, and there's different types of problems where you would have to use this type of geometric mean. I would really suggest to get a good feel for both of them. If you look at the 8B geometry website page, it's got 3 videos right at the top that talk about geometric mean in general, and then the two different types, geometric mean for leg and geometric mean for altitude. Those are pretty good explanations, so I'm not going to recreate that, but I would suggest that you go there. Let's take a look back on our page so we can work our way through these types of problems that deal with the geometric mean having to do with altitudes. So up at the top of this page in your notes, you once again have this large right triangle, and I know it's not marked as a right triangle. We should probably have it marked as a right triangle. It only works if this is the case, where again you've got a smaller triangle here and a medium triangle here. They make up the large one, and the three parts or legs of those triangles that are important to us are the altitude, and then the two different parts of the long side of the large triangle, the hypotenuse. Okay, the other ones don't matter for now. They don't matter in this type of geometric mean. Side A here and side B would matter if we're looking at the leg geometric mean. Okay, for this purpose we're only talking about the altitude. Okay, so one of the proportions that we can set up is shown over here on the side, and this is really the key to all of this. Once again, I'm going to remind you, you can take a look at Theorem 7.6 and 7.7. The one that we're talking about here is really 7.6, the one for the altitude. Okay, so what this says is if we look at those three important parts, we can set up this equation or this proportion that has to be true, where d over f is going to be the same as f over e. And think about why that works. D over f, d is the short side of the small triangle, and we're comparing that to f, which is the long side of the small triangle. Okay, so short side over long side. The same thing is really happening here when we compare f to e. F is the short side of the medium triangle, and we're comparing it to e, which is the long side of that medium triangle. So there's no reason this shouldn't work based on what we've already talked about. So this is always going to be true. And if you look at the example down at the bottom of the page, again we have the same large right triangle split into a smaller and a medium right triangle, and because that is the case, we can say that this type of geometric mean proportion can be set up. So down at the bottom I also have those items listed. We've got the short leg of the small triangle, longer leg of one of the small triangle. We've got the short leg of the medium triangle and a longer leg of the medium triangle. Okay, and so when we see what those are in the picture, we can just identify them and then plug them in to the proportions. And regardless of what those values would be for those side lengths, we know that this proportion is going to be true. And you can see that we've got the same side that is going to be multiplied by itself when we cross multiply. Okay? The other side is going to have two different values, but one of them is always going to be the same. Okay, the same thing was happening up here. If we were to cross multiply, I got f times f, and then I would have something that's different. We're going to take a look at that next to see how that plays out when we've got actual values and we work through the algebra. Okay, so on the next page of our notes, we have the same type of problem set up, and I've got I've got a medium triangle and a small triangle that I'm going to compare. I'm not going to compare the large triangle in this case, because again, I'm looking for this altitude, this length, and this length. This altitude, though, is the small side of the medium triangle. It's also the large side of this small triangle. Okay, so I'm going to use those values and set up the proportion here. Okay, so first let's start with the small triangle, which is here. We'll start, and again, you could write these on the side to make sure you're not goofing this up. Let's put the small triangle in the numerator. We'll put the medium triangle in the denominator. We'll put the long side or long leg and the short leg there. Okay, so if I look at the small triangle, long side, that's the x value I'm looking for. Let me jump across to this part over here. Medium triangle short leg is also going to be x, which is kind of what we expect, and that's why this geometric mean is nice. It allows us to find that variable, and eventually it's going to be cross multiplied. Small triangle short leg is going to be 3. Long triangle medium triangle long leg is going to be 6. Okay, so it's pretty clear that we're going to have this value of x being squared, and it's going to be equal to the other cross product. So here we've got x squared equals 18. If I take the square root of both sides, I'd get x equals the square root of 18. Some people say, well, isn't that positive or negative? If we're dealing purely in algebra and numbers, yes, but in this case, x has to be a length, which means it's a positive value, so I'm not going to have a negative square root of 18 here. Okay, so that's how we can use the geometric mean to find that length. Well, what is the square root of 18? Well, we could simplify that a little bit further and say, well, it's going to be 3 times the square root of 2. Square root of 2 is 1.4, so somewhere around 4.5 or so in there, and that seems pretty reasonable. Now, one thing, as you get good with these geometric means and identifying that that's what you're going to use, if you see these 3 values, if you're looking for x as the altitude and you've got the other 2, very quickly you're going to be able to set up a proportion where you've got the altitude across from each other in this way. That's going to be the one that's going to be multiplied by itself, and then just fill in the numbers for the other ones. Doesn't matter if 6 and 3 there, if you had those reversed 3 and 6, you're still going to get this algebraic equation where you've got x squared times 18, and again, you'd work through those other steps. Let's take a look at the problem on the right. This one's a little bit different because we don't have the altitude here. Okay, so here's where we would use the geometric mean for leg. And this one's set up a little bit differently, and there's kind of a shortcut to it. But again, if you just think about these in terms of proportions that you're going to set up and you label the sides, for example, it looks to me like I've got 2 sides that I know of in the small triangle and 2 sides that I know of in the large triangle. If I label those out here, small triangle is going to be on top and large triangle is going to be on the bottom, and I know the hypotenuse of both of those, and I know the short leg of both of those, I'll be able to fill this in no problem. Okay, a small triangle hypotenuse would be y. That's the value I'm looking for. And that's also going to be the same value as the large triangle short leg. So y is going to be there and y is going to be there. So we're getting a type of geometric mean where we're going to cross multiply and get y squared. Okay, if I look at the large triangle hypotenuse, that's going to be this whole thing, which is going to be 2 and 5 put together. And then the short leg of the small triangle is the only thing I have left, which is going to be 2. So now when I cross multiply, I get 7 times 2, and that's going to be equal to y squared. Okay, if I continue that, that's going to be 14 y squared. Take the square root of both. Y is going to be the square root of 14. And so that's going to be your value out here. And again, you can double check, does that make sense? The square root of 16 is 4, so this is going to be a little less than that, maybe 3.8, 3.9, and based on the other information there, that looks appropriate.